I'm Tom Stohlgren, scientist. We're here on a little nature tour of Rocky Mountain National Park with the Fisher family. This is our first stop in Beaver Meadows. It was formed by a glacier about 12,000 years ago. The glacier's ice was up to a half a mile thick. What was left when the glacier retreated was this meadow, a climate very different than today. It was 10 degrees cooler, 10 degrees centigrade cooler during the Ice Age. We raced out of the Ice Age. We moved along for a while, and 4,000 to 8,000 years ago, it was 3 degrees warmer than it was today. And then, lately, we've been on a cooling trend, and for the last couple thousand years, and then all of a sudden, a little Ice Age hit. And between 1550 and about 1850, we had the little Ice Age. We've had a warming trend in the last 150 years, it can't be denied. But if you look around Beaver Meadows, you see signs of the past right before our very eyes. There are signs of vegetation change everywhere we look, and one of them is right here. This is a cactus. What's a cactus doing in Rocky Mountain National Park? High mountains, cactus, blooming. Well, maybe it came in about 4,000 to 8,000 years ago when the weather was just a little warmer. The climate was warmer than today. But it didn't leave, did it? It stayed pretty much around this area. In fact, if you look around, you find lots of little cactus hidden in the vegetation that's here now. These grasses, bunch grasses, great for elk to munch on. Well, the most common tree in all the foothills areas of Rocky Mountain National Park is the ponderosa pine. That's a classic ponderosa pine tree. They weren't here 6,000 years ago. They kind of moved into the area, and they took over another pine tree, limber pine. I was here taking a lunch break 20 years ago. Today I'm joined by scientists Bryce and Kyle Fisher. So I was taking my lunch break 20 years ago, eating a sandwich, and I'm wondering, what happened to the limber pine? Limber pine was a short needle pine, and it grows way out on the plains, 200 miles to the plains, and it also grows at the very tip top of Rocky Mountain National Park, up there by the snowfield. Where is the limber pine? And I'm eating my lunch, and then I looked up. I was sitting under a limber pine tree. It mostly disappeared, but not all of them disappeared. A few stayed behind. Charles Darwin was right. It's not about being the most common species in an area, it's about surviving. And this tree, limber pine, learned how to survive despite the fact there aren't many of them around. I thought, this is amazing. So we found cactus here from maybe 4,000 to 8,000 years ago. The limber pine probably came in right after the Ice Age, 12,000 years ago. There's little pieces of vegetation that stuck around during the Ice Age. They didn't disappear. Is that remarkable? That's kind of remarkable. All right. Ready for another cool story? Yeah. This is it. What we have here, I said, was the limber pine. It had survived the Ice Age. It was here maybe 1 million years ago in different places, but here for at least 12,000 years after the ice left. And it looks like it may last. This is a pretty healthy looking tree. But then, 100 years ago, a disease came over from China. Yeah, a disease called white pine blister rust. And white pines have 5 needles. And how many needles did this limber pine have?
5.
Oh no, that means that it might catch the disease from China. But don't you worry, because this tree's going to be safe as long as there are no gooseberries in sight. As long as there are no gooseberries in sight. Because the disease has to go through a gooseberry first before infecting the tree. What's this? A gooseberry shrub. Right next to me, there's a gooseberry shrub that could carry the disease, that could give it to the white pine. White pine blister rust could be right here and could kill this tree. So we saved it from the Ice Age. We saved it from competition from the ponderosa pine that came in 6,000 years ago. But are we going to be able to save it from this new disease? So less than 100 feet away is this wonderful creek. And I hear this nice bubbling brook. Can you hear the bubbling brook in the background? Probably. And that really bothered me. Why did it bother me to hear a bubbling brook?
I don't know.
What's this place called? Beaver Meadows. What's missing?
A beaver.
The beaver! Exactly! This should be a beaver pond! The whole thing, this whole area should be a beaver pond. But because velvet hats, beaver felt hats became popular in London in 1850, everybody started hunting beavers, trapping beavers, killing beavers to send them abroad to make nice hats. So beavers were clobbered throughout this whole area. Here we are in Beaver Meadows and there's no beaver. They're coming back. They're slowly making a comeback, but they're not here now. So what else is missing? It made me think beaver are gone, and they would have had a nice creek here, and the creek would have had more willows and more aspen around it for the elk to eat. The beaver gone. What else are gone? What else has been removed from Rocky Mountain National Park?
Beaver dams.
Beaver dams have, yeah. What other animals? Wolves. When was the last wolf killed in Colorado?
1940.
Yes! And what else is missing? Grizzly bears. When was the last grizzly bear killed in Colorado?
1979.
1979 is correct. So, we don't have grizzly bears, wolves, we don't have very many beaver. There's a few in the park, but not very many. And what else don't we have? The fish. The Colorado greenback trout used to live in these waters. And it liked ponds, and it liked rivers, and it liked creeks, but it was replaced by the other fish we brought in. We brought in rainbow trout, and brook trout, and German browns, and they outcompeted the native trout, and the native trout have all but disappeared. One small population remains in all of Colorado of the very native greenback trout. So we know that vegetation changes over time. Now, we can see behind me that we have some trees that were killed by bark beetles. That's fair. There are bark beetle infestations. Maybe every 20 to 50 or 80 years we have a bark beetle infestation. But because the climate has warmed recently, the beetles have been able to survive warmer winters. And so there's more of them and scattered all the way from almost from Mexico to Canada. We've had pine beetle outbreaks in recent years, causing a fire hazard in the forest. More dead trees, more fuel on the ground, more ability for a fire to get started. If only we could map vegetation and monitor it over time. So our research team has created vegetation time capsules. We've put in long plots, 20 meters wide, so 60 feet wide, and up to 2 football fields long. And we've mapped every tree in that big long swath. And we put 14 such transects out all over the park. So ecologists can come back here 20 years from now, 50 years from now, or 100 years from now, and actually measure the trees and find out what survived and what did. Fire is a natural part of nature, much like sunshine and rain. And these forests depend on fire to regenerate. In this case, the ponderosa pine can get a small light fire. This is a small kind of light fire, and its heavy bark protects it so that it survives. The seeds open up when the canopy opens up. The forest canopy is now open up. There's sunlight coming through, perfect for pine seedlings to regenerate. Now this might happen every 30 to 80 years. A fire may come through. But what's happened around Estes Park and a lot of towns in Colorado is we've doubled the population that's living in the ponderosa pine belt about every 20 years. People are building their homes in a vegetation type that is very prone to fire. We know that going in. Fires and ponderosa pine have been together for many thousands of years. When you add a house to it, you're just adding more wood to that fire. Here's some nice regeneration that has come in after the fire about 10 years ago. And these are, how many bundles, how many needles per bundle?
2.
2 or 3 needles per bundle. So these are ponderosa pine coming back after the fire. So even if fire kills 1 or 2 trees or several in an area, it opens up a spot for many young ones. So it's a way for a forest to keep young by burning. So we're at the site of the Beaver Meadows elk exclosure. It was put in place over 40 years ago. So you can see on this side of the fence, there's aspen and there's large shrubs, sagebrush, lots of trees, but mostly the aspen are much taller. However, on the outside of the enclosure, there's hardly any aspen, not that many shrubs. So the superintendent of the park pulled me aside by the shirt and he said, even you should be able to tell me the difference between the grazed and the ungrazed part of this problem. Put out some plots and tell me what the difference in vegetation is. How much impact are the elk having by grazing? So I said, sure, I'll do it, as long as you throw in the exclosures in Yellowstone and Tetons and the Black Hills, all these nice places I wanted to visit that also had exclosures. So I could beef up my sample size and learn a whole lot more. So we put plots inside the exclosure and outside the exclosure, and then I put them randomly in an open area that was also grazed. What I found out wasn't what I expected. The diversity of plants inside and outside the exclosure was about the same. The grasses get mowed down here by the elk, but they're bunch grasses and they have really thick root systems, so they survive the grazing, inside and outside. Now there's less regeneration of aspen outside, but if you look around you still find aspen seedlings in fires, and you find aspen saplings all throughout the park. Aspen is the most common deciduous tree in all of North America. It won't be disappearing soon, and it won't be because of the because of the elk in Rocky Mountain National Park. So what we have here, I did the study, and then I found out another thing. I found out that measuring inside and outside of an exclosure may not tell you what you need to know. By putting in the embarrassing third plot, I found out that the two grazed plots were just as different as the grazed and the ungrazed sites. So really what we're measuring all along are just differences in sites. And if you look around, you can find the shrubs still in the landscape, hiding out, like the limber pine did a while ago. And you find aspen trees throughout the forest, hiding out, waiting for a better time. It's hard for a species to go extinct. It really is. You have to drive them there. If you look in a dry area with dry soils, low nitrogen, you find a small number of plants, very little plant species richness, they call it, the number of different kind of species living in an area. In 1 meter squared, you might find 5 to 8 different species living in that 1 meter squared. But if we were behind me and went to the wet meadow area, you might find 20 species in the same size plot. So we measured this all over Colorado and all over the Rockies and in Montana and Wyoming, and we found the same thing. If you have a dry area that's low in nitrogen, you have a few number of species, and if you have high light, high nitrogen, and high water, the good life, dun 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 dun, the good life, high light, high nitrogen, high water, they love to grow there. And so there's many more species in the wet areas of the meadow than there are in the dry areas. Then what we found is plants from other countries that were coming in targeted not these dry areas that are open, but the wet areas. If you had a large number of native species, you had a large number of exotic species, alien species from other countries. And it was the opposite then of what previous scientists had thought. They thought there would be plenty of room up here to grow, so they should invade here, but they weren't. They were invading the best places for life, for living, the good life. Dun 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 dun. So what was good for native plants is good for exotic plants, alien plants from other countries. So we're gathering our location with a GPS, and here's how we report the locations of alien plant species, animals that we see, a bird that died of disease, or anything in nature that we want to map or model. We can do it with the help of a GPS. Always, everything has a location, a latitude and a longitude and an elevation. The more accurate this is, the more accurate our spatial models will be.